WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the ECO Learner Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch ECO Learner Support for WAEC and NECO candidates on this station. Learners can also connect with ECO Learner Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. ECO Learner Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello learners, welcome to ECO Learner Support for WAEC and NECO candidates. I'll be your physics tutor for this class. This class I'll be taking you through elasticity. Let's go.
ECO Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So this is elasticity. Under this topic today, look at what we'll be considering. We'll be considering the meaning of elasticity. In case you have heard the word elasticity, what does it mean? We'll look at it in this topic. We'll look at Hooke's law. It's a law propounded, but it works within the spheres of elasticity. Also, we'll look at other terminologies that we'll make use of in elasticity. So with that, what are those things you should have in mind? At the end of this lesson, you should be able to define the word elasticity. So which means that going on the streets or you meet your junior ones, they should be able to ask you, I have heard of this word elasticity. Can you tell me the meaning? So at the end of this class, you should be able to do that. Not only that, you should be able to state Hooke's law. Hooke's law, like I said, it works within the sphere of elasticity. So you should be able to state what that law is. Also, all of that terminologies we'll be considering, you should be able to describe them, tell somebody about it. Now, elasticity, from the word elastic. When something is elastic, it means it can go beyond its original size. So, and for that to happen, it means that it must be under the influence of force. So, when we say something is elastic, it means it can increase in size. So, when we now talk about the word elasticity, it means the nature, the characteristics, the property of that material that makes it to still remain or regain its size, its shape, after the force that is distorting it has been removed. This is what I mean. If you have this size now, let's say this is a wire, and a particular force is applied to pull it out. So it now became this long. When you now remove this force that is acting on it, it should be able to return back to the original size. If this material should act this way, that property in it that makes it still come back to the original size and shape is what we call elasticity. So that is what we are talking about in this class. So when we talk about elasticity, a particular scientist worked on this elasticity and he came back with a theory, and that's what we call Hooke's law. When we talk about Hooke's law states that whenever you experience an extension E in any elastic material, that extension is caused by a particular force. So there is a linear relationship between that force and the extension. That is what Hooke's law is saying. So Hooke's law is saying that for every extension produced, there is a linear relationship between that extension and the force. So we look at it. Let's check it word to word. Hooke's law states that the extension produced by an elastic material is directly proportional to the applied force provided the elastic limit is not exceeded. Always take note that there is a clause. Provided that elastic limit is not exceeded, then you should know that different materials have different elastic nature. Each material, as unique as they are, their elasticity are also unique. So the elastic nature of a metal is different from elastic nature of a plastic. So let's take note of that. So from Hooke's law, we say that force that is causing that extension has a direct relation with the extension it produces. So which means that for every extension you have is a function of the force acting on that body. So which means if you have a body this way, if this is the length of the body, if you have additional length to it, so which means you now have it this way, so this extension you are having is a function of the force that you have applied. So which means that if you apply a larger force, so if you apply a larger force, you will have a longer extension. That is what Hooke's law is saying. But all of this will happen provided you have not exceeded the elastic limit of the material. Now, if you do that from this part, look at what we have here. We said F equals to KE. When you remove the proportionality sign, you introduce a constant and an equality sign. So that constant is what we call the force constant or stiffness constant. So it is given as K, which is F over E. But if you are looking for extension, you can make extension the following formula, which is F over K. The next one, look at what you're going to have here. For force constant is defined as the amount of force that causes a unit extension. It is the ratio of the force to extension of the material. Look at this. So when we say we have F equals to KE, so from here we can say K, which is F over E. So that force constant is our K. It's talking about the force that is causing an extension in that material. So look at it. What is happening is that the amount of force that will cause a unit extension is what we call the force constant. That's what you have here. Now, from Hooke's law, there is a graph that explains Hooke's law. How did you arrive at this graph? This graph is a function of the relationship that exists between the force and the extension. Like we rightly said from Hooke's law, F is equals to KE. So there is a relationship between F and K. It's a linear relationship. What happens is that as F increases, the value of extension produced increases. As F decreases, the value of E also decreases. So which means that when you plot a graph of force against extension, you experience a straight line graph. That graph is divided into two parts. We have the region of elastic deformation and we have a region of plastic deformation. So for the region of elastic deformation, Hooke's law is obeyed in the sense that the object's same size and shape is regained when the distorting force is removed. But for the plastic deformation, once an object gets there, it's a point of complete damage, no return. So for elastic deformation, that is the only region where this Hooke's law holds. So crossing to the plastic deformation, Hooke's law does not hold. So if you are solving any question and the limit exceeds elastic region, then Hooke's law should not be applied in that case. So from point O to E, that is the elastic region. That's where we call the elastic region. And then from point E and beyond, that is where we have the plastic region. So from O to E, within that place, you have the elastic limit. At that point where the elastic limit is talking about the maximum length to which it can be stretched. So that is the elastic limit. So let's assume as an athlete, you can run 100 meter race, 200 meter race, maybe 1,500 meter race. You know you can't go beyond that. That is your maximum. That is your limit. So which means you have an extent to which you must not exceed. Now look at this. That is the elastic limit. The yield point. The yield point is talking about the exact point whereby the material loses its complete elastic property and become plastic. So that is what we call the yield point. All right. So from this place, crossing the elastic limit, crossing the yield point will lead that object into plastic deformation. And if that force causing the deformation is not removed, you will soon see that it will reach a point that it will fracture, it will break. So at the point when it is breaking, that is you can see the physical damage that has been done to it. But just before that happens is what we call the maximum load. The maximum load is the highest or the largest force that can act on that object before it separates or before it fractures. So the next part, we'll make use of some terminology in elasticity. Like I have explained, the elastic limit, I have explained it. The yield point, I have explained it. And also the breaking point. The breaking point, I have explained that also. Now let's look at terminologies used. Let's continue with terminologies used in elasticity. There's what we call the tensile stress. The tensile stress is defined as the force acting on the unit cross-sectional area of a wire or a rod, or force per unit cross-sectional area of a wire or a rod. So what we are saying, when we say tensile stress, please I want you to be careful, because when you are making use of the word, most cases as young physicists, learners, you make use of the word stress. It's fine as stress, but we have other kind of stress. So the one we are talking about here is that tensile stress. We are being particular. Please take note. We have shear stress. We have bulk modulus. We're not talking about that. We're looking at the tensile stress. So take note. So tensile stress is defined as force acting per unit area. And we also talk about tensile strain. Tensile strain is comparing the increase you have gained with the original size. Let's assume you have somebody now. Let's assume you have a student of this height in GSS1. And in SS1, the boy is now of this height. When you compare this height in GSS1 with this height in SS1, you will see that there's an increase. You will now decide to compare the increase here with the original height. That is, you are comparing the extension with the original length. So that's what happened here in strain. Strain does not have unit because you are comparing the same unit. So you cancel, the units cancel out. So this strain does not have unit. So tensile stress, tensile strain. So when you now compare tensile stress and tensile strain, you have what we call Young's modulus. So Young's modulus is comparing the ratio of the tensile stress on a material to the tensile strain of that very material. So Young's modulus is given as, you remember that tensile stress is force over area divided by tensile strain, which is extension over original length. So when you solve this mathematically, you're going to have F over A times L over E. So all numerators multiplying themselves, you are going to have FL. Then all denominators multiplying themselves, you are going to have AE. So that was what bettered FL over AE. Now, let's look at what we have learned and check up if you have actually picked the important information as stated in the objectives. Look at this. Define elasticity. Okay? State Hooke's law. Not only that, describe these terminologies that will make use in elasticity. Number one, you are going to check the meaning of elastic limit, the yield point, and breaking point. I'll give you just a minute. Ruminate over this, produce your answer, and I'll be back. Okay, now that you have gone through that, I want us to compare notes. Let's see what you have, and then let's check up and put and correct where necessary. Look at this. Number 1 says define elasticity. Elasticity is the ability of a material to regain its original shape and size when the distorting external force is removed. Please don't forget to put this condition. The distorting external force must be removed before we know whether it's elastic or not. If when we remove it, it does not regain its original shape and size. Take note, it is original shape and size. That's it. Number 2, state Hooke's law. Hooke's law states that the extension produced by an elastic material is directly proportional to the applied force, provided that the elastic limit is not exceeded. So once you are stating your law, your Hooke's law, you must put that condition. If that condition is not included, you are wrong, because you have just made a statement without restriction. That restriction is what makes it hold for Hooke's law. Now, the other part, the elastic limit, is the maximum force which a body can experience and still regain its original shape and size. The B part says the yield point, which is talking about the minimum force on an elastic material beyond which plastic deformation sets in. Then, the breaking point. This is the point where the material can no longer withstand any further load. Beyond this breaking point, the material will shred into different components. It will fracture. It will separate. That is breaking point. With this, I know you have learned something about elasticity today.
Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So in case you have question, observation, suggestion, please forward everything to our social media handle and we'll be waiting to hear from you. Thank you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the ECO Learner Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch ECO Learner Support for WAEC and NECO candidates on this station. Learners can also connect with ECO Learner Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. ECO Learner Support for WAEC and NECO candidates. Pass your examinations with flying colors.